Oh, we're muted. Not anymore. Hey, Ice Cream Codes. Maybe you saw the fist bump. Thanks to Ice Cream Codes for coming into one of the early sessions this week and helping me with a little bug. That was really nice. Always good to see you. I hope it's a good Friday for all of you. We made it to the end of the week, so that's always a good thing. Right now, we are looking at a Roomba, and if you saw me pointing to it when I was muted, you saw the Raspberry Pi, you saw the camera. We set up the camera last week, and this week we're going to do some fun things with it. So we got to the very beginning of facial recognition last week. I've got that all cleaned up and set up. That works. I've got it trained to take a picture so the robot can take a picture, then recognize the faces in the image. I've also added label detection, so object detection. So in here we've got a camera image class now, and it goes through and does recognize people, so we can see all the people in the image that are recognized. And then even if they're not recognized, we get them in detect labels. So part of detect labels gives you the person, so it'll give you a bounding box for a person. So what this does is runs it through AWS or Amazon Recognition, gives us bounding boxes. I use those to draw boxes around it, and I'll show you a good demo of that in a second. In fact, let me show you that here. Be sure and put your, hey Jenny, welcome, glad you're back too. Be sure to put your comments in the chat, and I'll be happy to answer those comments, questions, whatever you have. So let's see. Let me show you Amazon Recognition in case you missed that part. And what I'm going to do, it's got a lot of cool features. I'm not using all of them yet either, but let me see if we can get a demo going here. Let me log in real quick. And I'll show you a demo of how it works because it gives you a lot of features that I think you'll find fun. So one of the features it gives you is the ability to tell emotions. So it can look at your picture and see if, let me focus on this before I mess that up. Tell you if the person you're uploading a picture of, for example, is happy or sad or angry or upset. And maybe you tailor your conversations around what the robot sees. So if the robot camera picks up someone that's happy, maybe you give it a different message than you would if someone was sad or angry. So you're noticing emotion. You can now kind of use that to tailor your responses a little bit more. So let's look, and I'll show you a quick demo of that. I think what I'll do today too is use a new image. So we'll use one that hasn't been trained just so you can see. Let's do face analysis. And we're going to upload an image. Now, who are we going to work with today? So I've already cleared this with my buddy, Justin. And we're going to use Justin's picture. And we're going to see what recognition says about Mr. Jeffress. So we're going to save this here. And we're going to go to the console, upload Justin right here. All right. Justin's on too. Good. So Justin, congrats. Recognition says it looks like a face 100%. You're most likely human. You appear to be male. You appear to be 29 to 45. That's a broad range, but that's pretty cool. Smiling. Look, it is a smile. And it's 80% sure roughly that it is. You appear to be happy. Congratulations. And you're wearing glasses. So that's all data that you can get from your camera. So imagine having your camera on your robot and being able to do not only facial recognition, but to also be able to tell a little bit about the person. So I don't know if you want to tailor it to gender or age range. I think Jenny had the point last week about looking for toddlers in the room. So if the robot is going through the room, maybe we don't want to go through a room if there are toddlers present. So that might be a cool thing to do. All right, Ice Cream Code says you are not hot dog. That is very true. You are not hot dog. And I think it would show celebrity if you were a celebrity, Justin. So you're not quite celebrity status, but you're a celebrity in my book. Okay, so that's just recognition. Now we're doing this in the console here. What I'm doing is doing it all in Python when we get to the Raspberry Pi. So what we're going to do today is I'll show you where it is, what state it's in now, and then we're going to add a new intent to our skill that says take a picture, and then it will give us the data that we want, and then we'll have fun with that data. So just a quick recap. Let me show you where we are on, if you're just joining. So we've got, go to the chalkboard. So we've got for all intents and purposes, it's a Roomba. It's actually a Create 2 from iRobot, and in the past couple of weeks we added a Raspberry Pi to it, and then last week we added a camera. So now from our Echo device we can say something like go forward, spin around, take a picture, and in this case today we're going to do take a picture, and it's going to do objects, it's going to do faces, and then we want to send that back to the Echo. So how do we do that? what we're going to do is take this data here, it's a terrible bracket, and we're going to add it to a DynamoDB database. So we're going to add the data of objects and faces to a DynamoDB database. And then what's going to happen on this part, so the skill, you've built skills before. If you're watching this, you've most likely built a skill. The skill is just going to do a little sleep. I'm going to sleep for a few seconds. So let's say 3 to 5 seconds while this magic happens. And then after that is done, it's going to make a call to DynamoDB and say, hey, what did you see? What objects did you see? What faces did you see for this particular session? So we have a particular session we're looking for right here. We'll call it session ID. It's going to get that data. It's going to bring it back. And it's going to say, hey, I saw Justin, and I saw a toddler, and I saw a piano, whatever it might be. So that's what we're going to do today. Let me see if I have any questions. Did you know that today is the Area 51 raid? Oh, it is. I did not know that. Actually, I do want to hear you sing, Justin. No, the Area 51 raid, that sounds really cool. That's the one where everyone's going to descend on New Mexico, right? I want to know what happens with that. I hope everyone's okay. I just hope we see some aliens too. Okay, so let me show you where we are in the code. I've got a listener. So this listener lives on the Raspberry Pi. The listener is a MQTT topic, so it's listening on 2 topics right now. We're listening on voice drive. Everyone see the font? Let me close this out a little bit. So voice drive, and that listens for things like go forward, turn around, go backwards, speed up. And then the second topic it's now listening to is called camera. And so camera is going to listen for a few things. So let me show you the camera image callback. It's right here. So this is going to take a picture. So it's physically going to take a picture with a Raspberry Pi Cam. Someone brought up last week, by the way, that the Pi Cam is not great for either long distances or really good resolution, and that's true. This is version 2 of the Pi Cam. Version 1 wasn't that great. Version 2 is a little better. But what I'm trying to do is not only make the code accessible for you, but also the cost of components. So the Raspberry Pi 2 Cam is like $30–35. It should be. There are definitely better cameras, but they're more expensive. But if it's important for you to have good vision for your production robot, then you would probably want to get a bigger and better camera. But this works great for you if you're trying to learn. All right, so it takes a picture. Let's see. So the topic gets a payload, and it says, okay, what are we listening for? We're listening for the phrases take picture, take a picture, or picture. So this is a lot like intents. When you set up your intents and you're saying, what do we want to listen for? You can do the same thing in this code. So if our topic sees any of those, it does a picture, it takes a picture, recognizes people, detects labels, and then saves the scene. So save the scene again. It saves it to a file. It uploads that to S3, and I'll show you why later. And then it saves it to DynamoDB, so Alexa can get it. So let's look at. Let's go add the intent first. So let's do developer console. What was this what was this? Does anyone know what's happening here? Rugby World Cup 2019. Any rugby fans? I tried it one night in college. There was a what do they call it? Intramural rugby team, and I tried it, and it lasted one night, and that was it. I did not do. That was not the sport for me. I got sidetracked, didn't I? Let's go here. No, let's go here. And there. No rugby fans showing up yet? Wow. I think two-factor is going to get me on this, so let me get my code here. This is your weekly reminder to set up MFA on all your accounts. Okay, let's go to it. Skills get maybe. Okay, Twitch robot. The Trinity played in high school PE. Wow, what a mess. Yes, I agree. All right, so here you can see our intents that we already have. We have a hello world, we have stop moving, we have spin around, and we have move. We're going to add a new intent called picture intent. And what might a user say? What do you think? Take a picture. Take a pic. What else? Capture a photo. what do you see? Because we're going to be asking the robot, what do you see? Tell me about the room. Tell me about the room. Anything else? Anyone have any more? Snap a photo. That should be enough for now. We've got that. Let's save that and build it. Alright, while that's building, let's load Lambda. We'll have to adjust some things there to our existing skill. And I'm going to duplicate this, and we're going to say, we're going to go to DynamoDB, and I'll show you what the table looks like that stores the data. So you'll want to create a table first. I call mine Twitch Robot Scenes. So you can see in the code we have a camera package, and it just sets up a few things. I set up a bucket where I'm going to place the image. I set up a few. I grab the image and I make another copy of it called annotated images or image, and that's where we'll draw boxes around it. We'll label things. You saw the collection last week, so that's what does facial recognition. Labels. I'll show you. In fact, let me just show you what it looks like now. So we'll take a picture now without Alexa being involved. Here's where it saves it to the table. So it's saving to Twitch Robot Scenes based on the session ID, any recognized people, and any labels. So you can see here that I've got a few. So we'll pick this one. So this one labels, it saw person, it saw clothing, recognized people, it saw me, and it just attaches it to a session ID. And you want to do that because Alexa Skills Kit will go, or Lambda will go and look based on that session ID to get the most current things it's detected. So let's do a little test here. So right here, I'm SSH into the Raspberry Pi. We're in the Twitch robot directory. All right. If you can't see that font, just let me know. We'll adjust it. So I want to do, let's see, I want to do Python listener.py, and that's going to listen on those two topics we talked about. So I'm listening on voice drive, listening on camera. Now last week what I was doing is going to the AWS IoT console and sending a test message. This time, to make it a little easier so I don't flip back and forth, what I've got is a payload file. So this payload file says, it's a JSON blob. So it says, directive is take a picture. The data I'm sending with it is called session ID, and it's a value of local. So all I'm going to do is just say AWS IoT data publish. I'm publishing to the topic camera, and I'm sending this payload right here. So when I do that, it's going to kick off that Python script that you just saw. And it will take a picture, so I'm going to get ready for the picture. Let me get this out of the way. Hey, Startup, how are you? I hope you had a good time at VoxCon last week. Did you get to meet Amit and Sohan and Kirsch and Paul? Looked like a fun time. All right, we're going to take a picture. Let's see if this works. I'm just going to stare at it because I don't like smiling for this camera while this camera's on. All right, so you can see already that it found me, and now it's going to add a person to the database. It's 99% sure I'm a person. It labeled me. Let's see. Oh, label. So it really only found one label, which was a person. But what it did is it saved it to a JPEG file. So what I'm going to do is show you that JPEG file. So we're going to copy that over to our desktop so we can look at it. We're going to look at it with Paint. So this is annotated. This is the picture it just took. Whoops, let's spell it right. There it is. So I was talking. You can see we've got an Amazon orange hex code right there. That green's a little dark, so we might adjust the green, but it definitely highlighted a person. All right, let's see what else I can get. I've got another prop here. I'm going to see if it will recognize this book. So we'll do the same thing. Okay. Good. It got a book. It got a book. It got a person. It got, looks like that's it. Let's check it out. And let's look at it. Cool. All right. Yeah, the font is definitely, let's change that color. Let's just change the color real quick. Anyone have an idea? Let's see. What do we use? We've used that's Whole Foods green that we used from episode 1 or 2. Hex codes. Unicorn. Pink. Let's see what this looks like. You know, typically sites that label things or annotate use a neon green. we could go with that, but I'm going to try this one. So let's go look in our draw code. Let's see, it's under here. So when I label recognize people, I make it orange. Labels are something different. So I want to change that color to that. And then the text color, it comes in the RGB format, which we need to figure out, which is, does anyone see it? It's not here, right? Let's just do this. Is this it, you think? 48, 18, 32? Let's try this one. 250, 94, 167. Alright, so we're going to change that up just so we can see that a little better. We'll try it with a new prop too to make sure everything works right. So let me grab another prop. 1 second. I'm going to use my son's guitar. Alright, let's take a picture. Oh, we need to restart the listener. Since we changed some of that, we'll restart this. Alright. I don't know if I got it up in time. Let's see. Jeff Nunn. Label. Leisure activities. Alright. Apparently, holding a guitar, a child's guitar, is a leisure activity. And let's look at the picture. Okay, there's our pink. That shows up better than the green. Alright, cool. So that works. So we know our picture works. We know that the labeling works. Let's just make the skill work now. Alright. So we got to here. Let's go Twitch Robot. Okay, so we need to add a new intent for picture intent. Let's bring this over here. Alright, so I'm just going to copy. I'm going to start off with an intent we already have just to kind of help us get going faster. Let's go with, here, stop moving intent. We'll copy that. And blow this font up a little bit for you too. Whoops. Alright. So stop moving intent, we're going to call picture intent. Can't handle function. Okay, so all of that is good. Alright, so here's what we're going to do. We're going to say, let's see, takes a picture and reads out the results. So step one, we're going to say grab the session ID. We need that. Step two would be to send an MQTT message. Step three is wait with time sleep. 4, we're going to wait, then we're going to do a DB query, so query DynamoDB for the results. Now if we have time, what time is it? 20 after? If we have time, we'll use APL to grab the picture and display it on our device. So APL to show the image. Alright, so we have 40-ish minutes. You're learning a lot about Python. Well, I hope it's good. I hope you like it. I was Node.js for the longest time, and then once I got more into like ML and AI, I had to move to Python by just because, and I actually love it a lot now. And you don't have to deal with callbacks, which is kind of fun too. Alright, so APL to show the image. Alright, so this will be pretty straightforward, I think. So get session ID. So session ID is going to be request, what's it called? Oh, handler input. So handler input dot, there's some kind of envelope, right? Envelope. There it is, request envelope dot session ID. That is going to be, whoops, that's going to be our session ID. Step 0, done. Send an MQTT message. Alright, so we're going to send a directive. The format of this, if I go look at this method, so def send this, it's looking for a topic, it's looking for a directive. So what should it do? Should it spin around? Should it go forward? Should it take a picture? And then any data that we want to send with it. So let's go back here. Alright, so we're going to send this to camera. So there's topic. The directive will be take a picture. And let me go back to our code and just make sure that we have that in listener. Take picture, take a picture, or picture. So either, any of those work. Alright, so that's that. the data is going to be a session object. So we're going to say session ID. Let me see if this is right. Session data equals session ID. Yeah, that's all we want to pass, and we're going to pass this. Okay. So we've done that, so that's step 2. We have to wait with time sleep. I don't think I've imported time yet, so let's import time. Now this is the one part I'm still not sure that I like this method, that we have to sleep, because the skill is going to be waiting, and right now it doesn't give any indicator to the user that it's waiting, because it does need to wait for the recognition to happen, which takes maybe a second or two in the database write. So it takes 2 or 3 seconds altogether. I'm going to sleep for 5 just to be safe, but it's not the best user experience, but we're going to keep it there for now, and then we can come back and add to that later. Alright, time sleep, so we've slept, and then now we want to query DynamoDB for the results. So let's go figure out how to do that. So we're going to say Bodo3 DynamoDB. Did I spell that right? DynamoDB read item. Michael Bender. I started my lecture journey with Python and Flask Ask. Moved to Node when it died. Really interested. Good. Thanks for that feedback. That's great. So this, by the way, is one of my favorite pages in all of AWS documentation, because I should have memorized it by now because I've used it a lot. But it's just how to interact with DynamoDB. Really simple. This is really good code. Let me switch to the new UI. Yeah. Okay. But really good code for creating an item, reading, updating, etc. So if you're getting into Python, this page will probably pop up a lot for you. So I want to read an item, and let's copy. We're going to need these Bodo things here. Let's bring those over into Lambda. Already had client error, so that's good. What else do we need? Helper class, I don't need. DynamoDB resource, I need this. So that's just setting up our client and our table name. We'll bring this back into our intent handler. Okay, I don't need region name. It knows I'm in US East 1, and I don't need endpoint URL. So I'm taking those out. Table name, again, is Twitch robot underscore scenes. Was it capital S? Yep. Okay. Let's go back to this code, and we're going to just try except else. So this is what does the query for us. Alright, so response is table.getItem. The item key, the key is session ID. That's our only key that we have. So we're going to change this to session ID. We're going to pass the session ID that we grabbed. We don't have a title, we can do that. Let's just clean this up a little bit. Make it a one-liner. Alright. Probably a quicker way to do that, but there we go. Client error, okay, and then speech. Well, okay, here's what we need to get to now. So let's just start off with a blank speech. So the robot will say, so we're going to say take a picture, and she'll say, got it. Then that's when we do the work. So we have the response, and the response comes back in this form. It's going to say response.sessionID labels and recognize people. So we want to say, let's say someone's in the room. Let's say Jenny Marrow is in the room, and it sees Jenny Marrow. It should say probably the person it recognizes first before it says the object. So we're going to say try that. Here's where it succeeds. So item is that. If length of item dot recognize people, right? Recognize people greater than 0. Then we found people. So we're going to say speech is I recognized. Sorry, I've got to phonetically say it out. And then for person in item recognize people, we're going to loop through those people, and Alexa's going to say who she recognized. So recognized. Oh, person. So I recognize person. Is Blankenburg on this? Let's say Jeff Blankenburg's in the room and he's building an APL skill, because I've been watching him build his skill. And it will say I recognize Jeff Blankenburg. Jeff Blankenburg, so there's this hierarchy of Jeffs at Amazon. If I'm sure you've noticed, there's one important one at the top, and then way down you get Jeff Blankenburg, Jeff Nunn, and now Justin Jeffress is in the group too because he has Jeff in his name. So if you're watching this on, if you're not following Jeff Blankenburg on Twitch, you can go to his channel now, Twitch TV/Jeff Blankenburg. If you're following him, that's great. If you're not following, don't follow him yet. I want you to go to twitch.tv/JB Nunn. That's me. Follow me first. Let me catch up to Jeff. Make Jeff sweat a little bit. Make Blankenburg sweat, and then like 2 or 3 days later, go follow him too. I'm gonna try to catch that guy. All right, so we have people, and now let's see if item. We want to look at the objects, which are called labels. So if length of item labels is greater than 0, we're going to talk about the labels we found. So speech, I see, and then for item. No, we'll call it for label in item. For label in item labels. Let me get rid of this window here. I can't see these comments. I have this reminder window that keeps popping up. Copy your channel to the chat. Absolutely. Twitch.tv. Justin, put yours here too. Whoops. I don't know what it just did. Oh, I'm not logged in. I will, maybe if Amazon Alexa is watching, it can do it. And then, like, hit enter a bunch and then put Blankenburg's later. Maybe type it backwards. Okay, let's see where I was before I got on my, nefarious plan. Speech plus equal label. So she sees, I see, and then she'll say I see guitar, book, etc. One thing I can, let's do this. Recognize people equals false, and then recognize labels. What we'll do is this too. We'll say if recognize people, we'll just make this true. Recognize people equals true. So if recognize people, she'll say I also see. Whoops, let's go there, and then else she's just going to say I see. Oh, I'm sorry, y'all. Speech equals plus equals I see, and then we're going to add this loop here. All right, so if it sees people, recognize them, it sets this to true, and if it's true, she'll say I also see blah blah blah. If not, she'll say I see, and we'll read those out. Now if not recognize people and not recognize labels, we're going to say speech equals I didn't detect anything in the scene. This should be a Jeff or not Jeff check. Yeah. Alright. I didn't detect. Alright, that's cool. Put a period after that. And then we don't need this get item succeeded. Okay. And then we are going to get rid of this. We're going to get rid of this. We're going to return the response, so build speech. Alright. Did we do everything right? Let's start over. We got session ID, we send a message. Where does that happen? Right here. Camera, take a picture, we're sending the data. Alright, and then we're going to wait, and then we're going to query, and then we should be good, and we have 30 minutes. Let's test this out. Let me save that. There's Blankenburg's. Remember, don't unfollow him, just don't follow him yet. Make him sweat. We got to make that guy sweat. Did it save it yet? Alright, so we're going to test this. How are we going to test it? We're going to go to this, and we're going to say test. Yes, we're going to allow that. Alright, let's make sure our listener is running. Where's that? Here. Okay, it's running. Let's go back to the test. Open Twitch Robot.
Hi, I'm your friendly robot. You can give me commands like move forward, move backwards, or spin around.
Spin around.
There was a problem with the request.
I don't know what I was thinking. I don't want to spin around. I want to take a picture. Take a picture.
Amazon Photos is not supported on this device.
Ask Twitch Robot to take a picture. Okay, let's see what happened. Open Twitch robot. You know what we should do first is probably test this from Lambda.
Hi,
Let's
I'm
do
your
that.
friendly robot. You can give me commands like move forward, move backwards, or spin around.
So take a picture. I've got a test event set up. Let's test it. Name JSON is not defined. Okay, so we just need to import JSON. Save it. JP Nunn, or Jeff Blankenburg has 3 times your followers. Yeah, he does. That's why we can't let the Blankenburgs win. Tie is fine. Just can't win. Okay, test this. Just thinking about it. Let's see what happens. Really, we should... Okay, we have an error. Let's see. Bodo 3 is not defined. Thought I had Bodo 3 in here. Maybe not. Apparently not. Alright, import Bodo 3. What's that meme? I test my code in production. That's what's happening here. What's everybody up to this weekend? Don't say coding. You need to take some time off, I'm sure. Alright, test. I want to see green. No more red. No more red. There we go. Got it. I recognize Jeff Nunn. I also see person and wood. Okay, so we just need to add a couple of things here. We need to add... Alright. Let's go back here. Let's do this. So that worked. I recognize... And we need to say person plus comma. And then I also see label plus comma. So it saw wood, it saw person, and I think after got it, it needs to have a space. I thought I had that. What else did I notice up here? Let's see. Got it, I recognized. Okay, I think the commas will help with that SSML. Ice Cream Codes has that on a shirt. I don't always test my code, but when I do it in production. Is it the most interesting man? I think that's the one I remember. Daughter's birthday party, nice. Did you rent a pony or anything crazy? Don't set the bar too high. For if you do, don't tell my daughter. All right, let's test this out. Open Twitch robot. Why is it being so slow?
Got it. I recognized Jeff Nunn. I also see person.
I mean, that's good, but open Twitch robot. I want to start over. I may need to refresh the, I think I do. You can tell because it's taking so long and I'm sleeping for 5 seconds. Alright.
I recognized Jeff Nunn.
Let's do that. And just to make sure it's working, let's hold the guitar again this time. Allow, and then we're going to say open Twitch robot. Dog-themed party. We have a rescue.
Hi, I'm your friendly
That's
robot.
really nice. That's a great
You
idea.
can give me commands like move forward,
I hope they get
move
adopted.
backwards, or spin around.
Take a picture. Is it taking it, guys?
Got it.
Alright.
I recognized Jeff Nunn.
Okay,
I also see
that worked.
person, leisure activities, guitar, musical instrument, bass guitar.
I don't think that was a bass guitar, but that's okay. That's really cool that that worked. So let's go check out the picture, just see what it looks like. It should have copied it to S3. Let's go look at S3. That'll be the easiest way to do this. So what is it? S3.Amazon AWS. What is it? I'm gonna get this wrong. Jeff Nunn public is where it was uploading, and it's called annotated.jpg. Here, let's do this. Let's see, S3, AWS, Amazon, public. Is that even the right URL? Working with buckets. Getting the URL of a bucket. I should know this. There we go. I want this. When in doubt, go to Jeff Bar. Another Jeff. Look at that. Who is higher, much higher up that ladder than Blankenburg or I. Alright, so we're going to go and Justin. Jeff Nunn public. and it's called annotated JPEG. Let's see what it looked like. Twin UI. No idea what that is. Oh, Paint 3D. Cool. All right, so that's what it uploaded to S3. That's perfect. So we asked Alexa to do that. So good. We have how much time do we have? 20 minutes. So now let's try to get it where we can show it with APL. So let's think about that. Lambda. There is an authoring tool we're going to use. So if you haven't used it, let's go with the Alexa presentation language authoring tool. Ginny, did you finish yours yet? You ready to share it with the world? Authoring tool. Alright, template. Yeah, I just want a template. We can do this pretty quickly with a template. Because we're not going to... APL is really cool because you can use variables to get data in there, like data that changes. Since we know exactly where our image will be uploaded every time, we don't really need to mess with it too bad. So I'm going to start with this basic image template. Let's go to... Right now, it just starts off with this today's daily photo of cheese. It has a nice icon, a scale icon, and it has a cute little pupper looking at some cheese and wine. So what we want to change is, that's probably the background image, container image. Let's see what this one is. Let's see, container image, what's APL? Okay. We're going to edit this document, and then we're going to upload it into our Lambda function and use that. I've not watched previous vids. Oh, yeah, of course. Michael asks what facial recognition library. So I'm doing it in the cloud with Amazon Recognition. Makes it pretty easy. The drawback is latency. If you need really quick latency or low latency images, then you might want to do it on board. So I've started it on board with YOLO. I'm using YOLO to do it, but I haven't got that perfected yet, at least for this broadcast. So I haven't shown that one yet. So right now it's cloud-based. There will be an episode where I'll do all onboard based. So it'll do everything and have a model on board that just does all the recognition for you. It'll be the same Python code after that, though. Once you get the image and draw the boxes, everything else will be the same. Okay, so I'm going to take this base document and I'm going to change. I just want to change this pupper to my image. So container, is this it right here? Source is 0 URL. What happens if I delete that? Yeah. So we're going to say. We're going to take, this is the picture. Where's Jeff Barr's blog? Right here. Whoops, let's go to that. So this was the picture, right? Public, oh no, it's Jeff Nunn, public. And then, what was it? Annotated. Let me show you one more thing too. If you do this, I'm sensitive to S3 security, so you need to make sure. Like, I have a public bucket. If someone looks at that bucket, you're going to get pictures like this. It's not a big deal. But when you upload those pictures, there is an ACL you set, and I'll show you where to set that. So if you go to Upload, Annotated Image, let me show you that method. It's right here. So it's just using the Bodo S3 client. I go with the file name, the bucket, the file name I'm uploading, the name of the file in S3, and then this extra args right here. This is what you want. So ACL public read. I have an idea to build a cat door that won't open for my dogs. That's a great, yeah, that'd be really fun. There's another, if you have the Deep Lens, I don't know if you have the Deep Lens, Michael, but there's a cool project demo that shows you how to do, like, a guy made a cat door, I think it was, for his cat. The cat had something in its mouth, it wouldn't open the door. Like, it had a little lever that sat behind the door where the cat couldn't get in. But if the cat didn't have anything in its mouth, then it would come in. Because this cat was bringing in rats and birds and things like that. It's a good video. I wish I could remember the link. I'll have to look for that and maybe post that one. Alright, so anyway, public read is what you want. We have 20 minutes to get APL working. Are you ready? Where were we? We're right back here in the APL. Alright, so we're going to copy that. Here, let's grab this and put it here. There we go. So that's a current picture, but I want it to be able to say, Alexa, take a picture, and it uploads it with a new one. And they want to change this daily photos of cheese to, obviously, to something else. So let's find that. Where are you, cheese? And I have, I think it's here somewhere. could be in the data. It's in the data. I know where it is. Okay, so we're going to go here. So the data is pulling it right there. And that's actually, let me go back here. This is the right way to do it. We're going to undo this change here. That should be a variable. We'll keep that the same. Data should be Twitch robot picture. Twitch robot picture. And then the image should be that. What is this? Large and small? We'll just make it the same. Cool. I'm not worried about this icon for now. I don't have a cool icon yet, so we're going to just leave that there. Okay, so we have that. Let's export this. I'm going to export this JSON, and let's just open it. Open it with code, yeah. Okay. So this is the document. So the document is going to, I'm going to make 2 files in Lambda. So one's a document file that kind of lays out all of our APL. And I'm going to the bottom right here. So this is our document. Make sure I grabbed it all. I've got it. Okay. And then I'm going to go back to Lambda and make a document file. So we'll go here. We'll open up this. Whoops, I don't want that. Where are my files? Right here. Okay. Let's make a new folder called APL. We'll keep all that separate. We're going to make 2 files in here. We'll make document.json. This again gives us the layout and all of our, templating. We'll save that. Before I do this, let me use JSON lint. So if you haven't used JSON lint before, it's a good way to make sure your JSON is valid before you make some mistakes. It also will do some nice formatting for you. So I had some extra spaces in there at the beginning. That just took it away, which is good. Go back to this, paste that, save it. I have document.json. Now we need data. We just need a data blob. And it is back here. And it will be this last section. And this is the data that we use to populate our variables in APL. So data sources. I don't know if I need. I think I just need this. Yeah. Copy that. And we can see our annotated picture there. Again, we're hard coding it. That's okay because that gets overwritten every time we ask Alexa to take a picture. So data.json is there. Okay, so now we need to load that. So I'm actually not good at APL yet, especially in Python. So there's a good demo. It's on the Alexa Labs, and it's called Karaoke. So if you want to learn this for, whoops, I want Node. If you want to learn this for Python, go to this. I guess I could type in Python, and it will take me to it. All right, cool. This will give me just what I need to help me get through this in the next few minutes. So we're going to go to the Python code right here. And it's going to let us bring in, I think I might already have brought these in earlier, ask model, these right here, the APL imports. So we're going to check our Lambda and see if I have those yet. I do, that's good. Let's go back to karaoke. And then we need to return that response. We need to add a directive. So let's go to add directive. This block of code right here is what I want. Okay. Good APL tips. Good. Let's go to little lambda right there, and all right. So take picture. We're going to take picture. All right. So we're on step 5. Before we return this response with the speech, before we do the end session, we're going to let's go ahead and add that period there, and then this. And we'll move set end session to false. You know, in the sleep part, where it's sleeping, the part that I didn't really like, you know, if we could play music right there, or maybe it's the sound of whirring or camera clicking, it might be pretty cool. Alright, so add directive. So token, we'll just call it picture token. Doesn't matter for this. Load APL document. That's a method in this demo right here. All it does really is just return JSON.load in the file. But we're going to go ahead and bring that over because it's kind of handy. And I'll just put it here. Oh, I have it already. That's good. Okay. So I've got that. Let's go back to this. Okay. Template data. So document is going to be called document.json. And then the data sources is going to be load APL document data.json. We could probably do it pretty simply by just putting hard coding our path in here. I'm going to do it this way for now. I'm going to take this out. There we go. It should be good. Let's save it, and we'll find out. I use, what is this? I use DuckDuckGo searching JSON validator, brings up a tool embedded in the search results. Oh. DuckDuckGo, and searching for JSON validator. Which is good, because you don't know if that JSON lit. So this is built into DuckDuckGo? I guess that makes sense on a privacy-focused website. Let's see if it breaks. Yeah, that's great. That's the best tip of the day. Thanks, Justin. Alright, our test, or save, let's test to make sure. We want to see green. Okay, that's alright. Invoke, what do we miss here? No, oh, I know what's wrong. So it's looking for document.json, but remember how I kind of namespaced it in APL? I put it in the APL folder, so we just need to add, let's add this, APL document.json, and then APL data.json. That's right, too. Save it. This takes a while to save, and you might be wondering, it's because all this gets loaded, so there's a lot of helper files in here for the SDKs. So it does slow you down a little bit, but it's still better. I think Node actually does it better right now as far as working from the command line and posting things up. Alright, test. We're going to see green. We want to see green. Reminder, Alexa office hours is moving to 9 Pacific starting Tuesday, 9/24. Alright, cool. So it allegedly works. Let's test it now in this. So I'm going to refresh just to be safe. Any more props? Let's see if it recognizes a phone. Alright, how much time do we have? 10 minutes. Open Twitch Robot.
Hi, I'm your friendly robot. You can give me commands like move forward, move backwards, or spin
We
around.
need to take a picture to that now. Take a picture.
Got it. I recognize Jeff Nunn. I also
Okay.
see person, electronics,
So that's
phone,
good.
mobile phone.
Now, I want to scroll down and see that picture, and if I do, we'll be happy. Yes, we got it. Okay, so, everything worked, which is always good. Now the fun part would be, what do we do with this? So now what do we do with the things we recognize? Do we use it to, like, if you're analyzing my picture, just like we did with Justin's at the beginning, I am happy right now, but it looks like I'm probably not happy, so maybe we're going to say, like, oh, we're going to tell Jeff Nunn a joke. I'm not sure. It's pretty cool, though. I'm going to depend on you, the lovely Twitch viewer, to send us your ideas on what we should do next with that information. I think that'd be really fun. What you can look forward to next on this show is we have a couple of surprises coming. I also want to get Alexa voice services in, so we're going to talk to those guys and see how they build microphones and speakers directly onto devices. So right now, of course, we've got the robot. We've got Raspberry Pi on top of a robot. This would be a robot with everything built into it. And we can still take our code and copy it over and do all of that, but that would be one of the next steps. And then, let's see, there was something else I wanted to show you. I think we'll use this probably for navigation. So I've got an ultrasonic sensor I'm going to attach to the Pi next, and we'll use that to ping our environment and try to make a map of it. I think that'd be fun too. And then ask Alexa where it is or what room it's in based on the data it gets back. Cool, let's see if there's anything else here. I do not approve this office hour switch right at lunchtime, makes me sad. Oh yeah, are you in Australia, Michael? Facewalk. Cakewalk and Facewalk. And then Amazon Alexa do office hours in Espanol change too, or are they at their normal time? Oh, New Jersey, okay. Spacewalk would be really cool. Let me show you real quick. Let me find this. Let's see, it was Amazon Deep Lens cat detector. And it was on YouTube. It was a good little Yeah. So I'm not gonna show this. I think it would block our Twitch, but here it is. So look for AWS DeepLens powered cat flap, and that will show you what you can do with DeepLens. DeepLens is we're building something similar to DeepLens. It's just DeepLens has onboard camera and onboard processing. You can do the same cat flap with the tools that we have here, Raspberry Pi, and some actuators. Okay, only English hours have changed time. All right, cool. Well, that's it. Any questions? I'll hang out for a little bit. If anyone has any questions or wants to see any more of the code, this code is, there are a couple of bugs. So one bug, if it doesn't recognize a person, so if I lean away from the camera, it doesn't recognize, it's crashing right now. It's going to be a relatively simple fix. I just don't have that fixed. So once I get that fixed, I'll post all this to GitHub. So the GitHub account, if you want to follow along, is this. github.com/jbnunn/twitchrobot. So I'll post the latest, and you can have up-to-date code. In the Lambda, there will be that Lambda code that you see here. I'll upload that, and then in the skills, where's skill? Ask model. Well, yeah, there's your ask model. So you'll get a new intent called picture intent. Okay. Spacewalk only allows, yeah. I want to take a spacewalk, that'd be fun. I think DeepLens have depth camera, the new DeepLens. Hey Serge, welcome. Let me see, I don't know about that. DeepLens depth camera. Depth cameras are really cool. I wish, so there's a depth sensor. You might be right. The new 2019. I'll have to research that. That's great though if it does. There's hot dog, not hot dog. This is ice cream code's favorite. But you can see it does a lot, and so we can also get pose detection from the recognition API. We get all of this too. DeepLens just has a nice bundle package for you. Let's see what else I can show you. There's one camera, if I can think of the name without having to search too hard for it here. There's a $65 camera that did inference, which would be onboard. So it, by default, recognized models, like it had a base set of models that it recognized, so you didn't have to do the onboard processing or even sending it to recognition. Oh, NanoNet. It might be NanoNets. Let's see. This is not it. So this would be one of the next things I do too, is doing it with video so you can see things moving. So then we could actually look in on the robot as it's moving around and identifying images. This is not it. Yeah, sorry, I can't think of that camera, but it's this FLIR one's an awesome one, if that's something you want. This might be it. This is around the same price point. But I don't think it is. Okay, it's not. Hi, I have the first one. What I use, I understand the new version. Main difference is a depth camera feature. That'd be great. That'd be really great because depth-based cameras are expensive usually. So I've got a Kinect. If you have an old like 360 Kinect, you can also hook it up to these things. But there are challenges because it's powered. So you either need to hack the wire to draw off the robot, or to have a cord running, which is not fun, or a big battery. That would really help with navigation and scene detection and route planning, the depth cameras. So that's really cool. DeepLens is going to be great, the new one. All right, well, thanks for joining, everyone. I hope you have a really good weekend, and you can always just keep subscribe to us here on Amazon Alexa. It'll pop up if you have notifications on when we're doing coffee sessions. So coffee sessions throughout the week we do to just kind of do behind-the-scenes stuff. A lot of times you won't learn anything. A lot of times it's me hacking around and Ice Cream Code's giving me hints on how to fix something I broke. But it's fun, and so if you want to join those, you can. If not, then we'll see you next Friday. All right, bye.